Greetings. Welcome to W2U4 Gagne's Events of Instruction Part 1. In the last unit, we understood Kolb's theory of experiential learning. In this unit and the next unit, we will discuss Gagne's theory of 9 events of instruction. So, the outcome for this unit is understand Gagne's 9 events of instruction part 1. Gagne considered the pioneer in designing and thinking in the direction of a systematic approach to instructional design and its related concepts, proposed a theory of instruction design called 9 events of instruction. Gagne was primarily a behaviorist, but his theory drew not only from behaviorism but also from cognitivism. This theory is designed to enhance the teaching and learning process. As I said, it is primarily based on behaviorism but draws from cognitivism also. Today, it is known that behaviorism is less in favor compared to cognitivism. But this theory of 9 events of instruction is found to be extremely suitable for a variety of instructional contexts. The focus is on how information is effectively processed and retained. Each event in this theory corresponds to a step in the internal learning process and helps guide instruction design. That is the idea. This theory uses the concept of conditions of learning that is central to Gagne's theory of 9 events of instruction. Conditions of learning can be internal and external. Internal conditions deal with previously learned capabilities of the learner, what the learner knows prior to the instruction. That is the internal condition with which the learner commences the journey of learning. The previously learned capabilities of the learner, they are the internal conditions. External conditions, that is stimuli. Notice that stimuli is a purely behavioristic term. Stimuli that is presented externally to the learner. The instruction provided to the learner. So, that is external condition. So, the learner starts with some knowledge which he or she has already acquired, and the instructor provides certain instruction to the learner, and this interaction leads to the learning. So, these are conditions of learning. They get reflected in the model of this instruction. The specific model that you design based on the Gagne's theory should reflect these events. According to Gagne, the 9 events of instruction need to be planned based on the intended learning outcomes. That means there is a flexibility, though there are 9 events, how these events are planned, how they are implemented, how many resources are committed, how much time is allocated to each event, that is all the choice of the instructor, and that depends upon the intended learning outcomes according to Gagne, but we also know that it also depends upon other parameters like resource constraints, etc. We will discuss again towards the end of the session these design constraints. The 9 events of instruction are event is gain attention. What is the activity that is done and what is the purpose of this? Motivate the student, present a good problem, an anecdote, ask questions, etc. You can see a similarity between this idea and Merrill's idea also, even Kolb's idea. In fact, most of the good instructional theories consider this as extremely important to begin the process of learning. First, you have to gain the attention of the learner. So, you have to motivate the student. Second event is describe the goal. State what students will be able to do at the end of the instructional unit, what we have been calling the outcome. 3. Stimulate a recall of prior knowledge. Remind the student of prior knowledge relevant to the current lesson or current goal. That prior knowledge can be facts, rules, procedures, or skills, or concepts, all these things which the instructor considers as relevant to the current topic, current goal, or current outcome. That the instructor must ensure that the learner is able to recall all these things. Show how knowledge is connected and provide the student with a framework that helps learning. The prior knowledge and the outcome, expected intended outcome of the current unit, learning unit, they are all related. So, show those connections. 4. Present the material to be learned. This is the phase where the actual new content is presented. So, that could be text or figures or graphics, simulations, whatever the instructor decides. So, present in small units of instruction and avoid memory load. This is a general principle. Then the fifth event is provide guidance for learning. Presentation of content is different from instructions on how to learn. We will discuss this again in greater detail in the next unit. Elicit performance practice. Let the learner apply the newly acquired knowledge, at least use multiple choice questions to allow the learner to practice applying the newly acquired knowledge. Then event 7, provide informative feedback. This again is considered extremely important in all learning theories. Analyze the learner's practice performance, provide feedback, and perhaps present a good solution to the problem. This is an optional step. If the student's solution is good enough, then provide that positive feedback to the learner. Event 8 is assess performance. Test the depth of learning. Provide general progress information to the learner. Then the last and ninth event is enhance retention and transfer. This is about the long term retention. This is extremely important, and we must ensure that the learner is able to retain this knowledge and skills for long term usage. So, inform the learner about similar problem situations and provide additional practice. We will discuss now these events in greater detail. Event 1, gain attention. So, as we saw, the purpose is to motivate the student. Maybe we can present a good problem, an anecdote, an interesting question, an interesting video, or an interesting historical event. So, something to motivate the student and gain the learner's attention. This is very important. For any learning to take place at all, first you must capture the attention of the student. So, you must gain the learner's attention. This event is necessary, and the student now becomes ready to learn and practice and participate in the subsequent learning activities. If that attention is not gained, then perhaps the subsequent events will not mean much in terms of learning by the student. So, instructor implements this event by presenting a stimulus to capture the attention of the learners. And how the instructor motivates the students is left to the choice of the instructor. The theory itself does not prescribe any specific approach for gaining the attention of the learners. This is instructor's choice, that is, how do we gain the attention of the learners. But some methods suggested in the literature for capturing learners' attention are a relevant multimedia presentation that startles the learners. The idea is there is something in the presentation which suddenly alerts the learners to something exciting. So, it startles the learners, perhaps a kind of an event which throws a surprise at the students who see that presentation. So, something to catch their attention. A thought provoking question or interesting fact in the very beginning. Again, this can lead to curiosity in the learners, which in turn motivates the students to learn. Stimulate students with novelty, uncertainty, and surprise related to the topic of the study. Something which essentially makes the students pay attention to what is going to follow. Have learners pose questions to be answered by other learners in a group discussion. Let the students be engaged in a small group discussion where they discuss something interesting about the current topic. So, some questions are posed and others try to answer, and then the rest of the people try to discuss these. So, something which really makes kind of break the ice kind of a session where everyone gets tuned to the learning environment. So, that is another way of gaining the attention. An example can be, assume that the learning outcome is at the end of the instructional unit, learners will be able to apply Nyquist-Shannon sampling theorem. Just as an example we are taking. So, this can be one nice way of gaining the attention can be start with a relatable multimedia demo. Play a short audio clip sampled at different rates. Example 44.1 kilohertz versus 4 kilohertz. And the students can see the effect of different sampling rates immediately. And the instructor can point to the quality distortion differences when the signal is sampled at one frequency 44.1 kilohertz and at another frequency 4 kilohertz. So, this can lead to some kind of curiosity, and that in turn can be used to gain the attention of the learners. Ask a thought provoking question. Why does music on an old cassette sound different from a digital recording on your phone? What really makes for this difference? So, this can be a question, and the answers need not be correct, and the answers do not have to be completely correct or everyone has to answer this. It is not like that. The basic idea is that stimulate and gain the attention of the learners. So, engage them in some discussion, and then the instructor gains the attention of the learner. Another example can be the learning outcome is apply Bernoulli's equation to solve engineering problems involving fluid flow in pipes and nozzles. Again, a small video clip can be demonstrated, and that can show a real world failure due to fluid pressure miscalculation. For example, a pipe burst. Most of the learners would have seen such an event in the real life, and there are video clips available. So, instructor could demonstrate such a video clip. Immediately, the learners will be able to relate to that event, that real world event. Now, we can prompt what caused this failure. So, let the learners share briefly their reasonings. Once again, it is not very important to see that the answers are correct or complete. What is important is that the learners engage in some activity which makes them ready to be active participants in the subsequent events. That is first to gain attention. The next event is describe the goal. Now, it is a well established principle that students learn better when they are made aware upfront, right in the beginning, of what they will be able to do at the end of the instructional unit. This is also the core principle of outcome based education. The outcome is what we are calling this particular goal, and outcome is discussed in the earlier courses such as TAIL, NET, OBEA. They were all on outcome based education. In all this, the OBE framework places utmost importance on the way the outcome is written and the fact that the students are informed of the outcome upfront, right at the beginning of the instructional unit. So, describe the goal. The outcome may be elaborated into competencies when required. As discussed in the above courses, this event initiates the internal process of expectancy and helps motivate the learner to engage with and complete the lesson. Further, we know that such outcomes should form the basis for assessment and such an alignment will improve learning. That is, we know that when the outcome, the instruction and the assessment are all aligned to each other, deep learning occurs. So, event 2 essentially is make the students aware of the outcome. When an outcome is elaborated further into a set of competencies, instructor has the choice of designing an instruction plan. Do we consider all these competencies together and design an instruction unit for the entire set of competencies? Or do we consider each competency separately, almost consider it itself as an outcome, and design the 9 events separately for each of those competencies? Instructor has the choice. So, each competency can be considered as an unit by itself. That means all the 9 events of Gagne are implemented separately for each competency, or the entire set of competencies is considered as one unit and all the 9 events of Gagne are implemented in an integrated way for the set of competencies. Though both are possible in principle, in practice one tends to use the entire set of competencies as one unit because of resource constraints. As it is, we will see later in the next unit that it is very difficult to implement all the 9 events in detail because of the practical constraints, particularly time and resources. So, generally, instructor tends to treat the entire set of competencies as one unit and all the 9 events of Gagne are implemented in an integrated way for the set of competencies. Of course, this does not exclude specific events to be planned separately for specific competencies. It is up to us. There is a lot of flexibility in how the instructor makes use of Gagne's theory. Example, let us say one set of competencies we are looking. At the end of instructional unit, learners will be able to notice that this is a set of competencies. Define heat transfer and explain its significance in the mechanical systems. Differentiate among conduction, convection and radiation. Identify real examples of each heat transfer mode. Okay. So, this is one set of competencies. There is solve simple problems of heat transfer applying the basic laws including Fourier's law, Newton's law of cooling and Stefan Boltzmann's law. So, all these competencies become one set. They are concerned with heat transfer. The other two competencies are related to sampling from the digital signal processing. Determine appropriate sampling rate for a given signal using Nyquist-Shannon sampling theorem. Understand aliasing and how to prevent it. So, this is another set of competencies. So here we have two sets. One set is related to modes of heat transfer and another set is related to sampling of the signal. Let us go to the next event, which is event 3, stimulate recall of prior knowledge. Help students make sense of new information by relating it to something they already know or something they have already experienced. Remind the student of prior knowledge relevant to the planned current learning. We already saw even in the Merrill's first principle of instruction the importance of activating the learner's prior knowledge structures to ensure deep learning. So, several theories see the importance of this event, that the learners must be able to recall prior knowledge so that using that as the foundation they can build with the new knowledge. They can continue from where they are at present to acquire the new knowledge and skills. It is part of most of the theories. So, stimulate recall of prior knowledge. The prior knowledge can include facts, concepts, procedures or skills, whatever is relevant to the current topic. That must be recalled by the learner and instructor must stimulate it. Show the learners the knowledge linkages. This is also important, how the knowledge to be acquired in the current instructional unit is related to the knowledge that the student has already acquired. These are all interrelated. So, show the knowledge linkages and provide the learners with a framework that helps learning. As I mentioned, we have seen in the early unit and merit principles also that building the new knowledge on the foundation of prior knowledge facilitates good learning. So, Merrill's principles also include this aspect. Some useful approaches for stimulating recall of prior knowledge: instructor could ask questions about previous experiences, guide the learners into a group discussion about the relevant previous concepts, help the learners in establishing the necessary knowledge connections. Some kind of examples: simulate recall of prior knowledge. Current topic, assume heat transfer modes. That is what we just saw in the earlier slides: conduction, convection, radiation, heat transfer modes. Ask the learners to recall the first law of thermodynamics. A quick discussion on the difference between heat and temperature. Refer to previous knowledge about basic properties of materials, including thermal conductivity. These can be some of the ways the instructor can stimulate a recall of prior relevant knowledge. Another example, current topic is Bernoulli's principle. Then instructor can ask focused questions on conservation of energy. This is from the domain of physics. You can ask the students to recall what is conservation of energy. Then continuity equation from fluid mechanics. These two are relevant for Bernoulli's principle to be understood. So, instructor can spend some time on ensuring that the learners recall this prior knowledge. The next event, event 4, is the actual presentation of the material to be learned. This event of instruction is where the new content is actually presented to the learners in an effective, engaging and efficient way. A common misconception is that instruction is all about this single event only. There is instruction means simply present the new material to the learners, that is all. There is nothing to the instruction other than presentation of the new material. This is a misconception. We already have seen earlier in the Merrill's principles, in Kolb's theory, and even the earlier 3 events of Gagne's theory, that there are several other aspects to instruction that must be taken into account in designing a good instructional model. So, several instructional methods are available to the instructor today, how you present the new material. In later units, we discuss some of these, including direct instruction, problem based instruction, project based instruction, instruction for design thinking, instruction for metacognition, instruction for critical thinking and problem solving, instructional methods that leverage generative AI tools and so on. There are several which are available to the instructor today. How the instructor uses these to present the new information is entirely his or her choice. So, in the next unit W2U5, we will present the remaining 5 events of Gagne's 9 events of instruction and conclude discussion of Gagne's theory. Thank you and we will meet in the next unit. Thank you.